Here are your solutions to Chapter 1, Lesson 6, Guided Practice. First problem is 9.931 times 10 to the 5th. We need to turn it from scientific notation to standard notation. So the first thing we're going to do is write out the 9931. Since it's a large number, add a bunch of zeros. And then we're going to move our decimal point those 5 places. So we started here. We're going to move 1, 2, 3, 4, 5. We don't need these zeros. So we're going to have 993,100. Don't forget to use your comma to make it easy to see the number. Number 2, we have 6.02 times 10 to the negative 4th. Clearly a small number because of the negative exponent. We're going to write the digits out, 602, add some zeros out front. We're going to move 4 places. This is the only way we can make this a smaller number is by moving left. We're going to move 1, 2, 3, 4. So we don't need that 0. We're going to have 0.000602. We should have 3 zeros between the decimal point and the first digit. Problem number 3. We have 8,785,000,000. So clearly we're going to have a positive exponent here because this is a very large number. We need to use the decimal point right there, so it's going to be 8.785, and then we need to count up how many we're going to move the decimal. And you should see this fairly quickly and easily as 369. We'll count it out so that you understand what I mean, but it's 1, 2, 3, 4, 5, 6, 7, 8, 9 places we move. But you should see this as 3, 3, and 3. So it is 8.785 times 10 to the 9th power. Number 4, we have 0.524, and we need to turn that into scientific notation. So right here is where the decimal point needs to be. So we're only moving one place, so it's 5.24 times. We're going to move one place, so it's a question of is it positive or negative. Well, in order to make this a smaller number, it clearly needs to be negative 1, small number. Number 5. First thing we're going to do is make sure we pay attention to the fact that they want them least to greatest. And in my opinion, this is a really easy problem for you because the powers in this case, the exponent of 6, 7, 10, and 11 says it all. This is going to add 6 zeros, 7, etc., etc. So clearly we just put them in that order. So we have 7.15 times 10 to the 6th, followed by this number here. And this is where you're going to look for your answers. So the third number was the least, then the fourth, then the second, and then the first, in this order here. In this case, you didn't even need to pay attention to the number that we were multiplying by the power of 10. Number 6, we're being asked about a plant cell. We could report the diameter of that plant cell as 1.3 times 10 to the negative 8 kilometers, or we could report that as 1.3 times 10 to the negative 2 millimeters. Very small unit here, a very small item here, a plant cell. The diameter of a plant cell is very small. Therefore, we're going to use the smaller of the 2 digits, the millimeters versus the kilometers. And the reason for it is because the plant cell is very small. We use the smaller measurement, 1.3 times 10 to the negative 2 millimeters. And lastly, your essential question: how is scientific notation useful? And the real easy to that answer is it is a much easier way to write a very large or very small numbers. Doctors, physicists, scientists, folks like that, mathematicians, use scientific notation often for very large and very small numbers.